So, number one, rotate DEF 90 degrees clockwise about the point -1, -1. So here's -1, -1 right there. 90 degrees clockwise, like we just saw, is one turn to the right. I'm going to turn my paper to the right, and I'm going to pretend this is my origin, and these are my image points. If these were my image points, D would be at 3, 2. So D would be at 3, 2. E would be at 1, 2, 3, 4, 5, 3. And F would be at 1, 2, 3, 4, 5, 6, 1. I'm going to turn back around, and now using this as my quote-unquote origin, I'm just going to plot these points. 3, 2 is D prime. What's up? You guys good?
Yeah.
Okay. 5, 3, 3, 4, 5, 1, 2, 3 is E prime. 6, 1, boom, boom, is F prime. E prime. There's my 90-degree turn. So what are D prime's coordinates? Andrew, you okay? 2, 1. F prime is at 5, 0. E prime is at 4, 2. All right. Give me a thumbs up. You got that right. Number one. Yusuf did. Colby did. Arisha did. Kaylee did. Andrew did. Good. Number two, reflect element N, or oops, I almost said element OP. LMN across the line y is equal to x, and write the rule. Well, what's the rule for that reflection? Y, x. That one's easy because it looks just like the equation, right? So all I need to do is take these points and flip their x and y. For example, if L is at 5, -2, L prime is going to be at -2, 5. Boom. If M is at 2, -2, M prime will be at -2, 2. And if N is at 5, 1, N prime is going to be at 1, 5. Right, that looks like a pretty good reflection. Let me draw my line of reflection to check. Yep, it looks pretty good to me. And that's a real easy way to get that one done, right? Okay. Now, alternatively, you could draw this line, and then from N, right, count 1, 2, 3, 4 spaces, 90 degrees, 1, 2, 3, 4 more spaces like that. You could do that too, it's up to you. Number 3, identify the pre-image and image coordinates for the transformation shown. Well, real easy. The pre-image, that part's super easy. -3, 4. B, 1, 1. C, -3, 1. And then what are my image coordinates? Well, A prime is at 4, 3. B prime is at 1, -1. And C prime is at 1, 3. Okay. What does it look like happen between my X and my Y coordinates here between these points? Alex, what does it look like happen? They swapped and the Y turned negative? Yeah, the X, because the X is now in the back, right? So if I take -3, 1, and -3, and I flip their signs and then swap their positions, that's how I get A prime, B prime, C prime. So the rule for that would be Y -X. What type of transformation has the rule Y -X? 90 degrees clockwise. Is that it? Nope. About the origin. Or around. I don't care either way. And that's what it looks like, right? It looks like we turn 90 degrees. C and C prime make a nice little 90-degree angle with the origin there, so that works out. Any questions on number 3? Okay. Number 4, quadrilateral with vertices at the following points is translated using the vector 6, -4. Real quick, how can I write that rule? X something something, Y something something for 6, -4. x plus 6, y minus 4. What are going to be my image coordinates? Well, I'm going to add 6 to all these x values. 5 plus 6 is 11. 0 plus 6 is 6. Negative 2 plus 6 is 4. 3 plus 6 is 9. And I'm going to subtract 4 from all my y coordinates. 0, negative 6, negative 1, negative 3. Give me a thumbs up, you got that right. Pretty straightforward, right? Number 5, determine what transformation is shown. Obviously, this is a reflection. But what's this reflection across? The y-axis?
The x-axis.
X equals 1. Right? Just find the midpoint between my image and pre-image. If f is 4 units from f prime, half of that is 2. Well, that's how far away my line of reflection is. Where does that line of reflection go through? Well, it goes through... Guys, stop talking. Where does that line of reflection go through? It goes through 1 on the x. The line is x equals 1. Nice and easy, right? Now my rule for that is a little bit more complicated. The rule, if we remember, is 2a minus x comma y. Well, a is 1, so 2 times a is 2 minus x comma y. That's my rule. Right? Now if I had a horizontal line of reflection, it would be x comma 2a minus y, right? So the one that I'm adjusting is the one that I'm going through the axis. Does that make sense? I think it makes sense. Number 6, PQR has these vertices. It's reflected across the y-axis, then translated using the vector negative 3, 4. So this one's a little different because I'm doing 2 transformations in one. I'm not doing one of them and then another one and having like p double prime. It's both of them in the one single transformation, if that makes sense. So let's just think about this. If I'm reflecting across the y-axis, my rule would be negative x comma y. And then if I have this vector, I'm doing x minus 3, y plus 4. So if I apply both these rules to these coordinates, here's how I can do that. I'm going to take negative 6. I'm going to flip the sign first, then subtract 3. If I flip the sign, that becomes 6. I subtract 3, that gives me 3. My other x coordinate, I'm going to flip the sign and subtract 3. If I flip the sign, it becomes 5. If I subtract 3, it's 2. If I flip this sign, it'll be 1. And then I subtract 3, it's negative 2. Right? We're getting these image coordinates without doing any sort of graphing or any sort of visual. It's all just algebraic rule. What do I need to do with the y coordinates here?
Plus 4.
Plus 4. Is that the only thing I need to do?
Yes.
Yeah. Because when I reflect over the y-axis, my y-coordinate stays the same. Right?
Yes.
But then after that translation, I'm just adding 4. Negative 9 plus 4. I'm going to do a little minus 3 down here. Negative 9 plus 4 is negative 5. Negative 3 plus 4 is 1. 3 plus 4 is 7. There's my coordinates. Anybody get those right for number 6? Yeah? 3 people, 4, 5, 6. Anybody do it a different way? Tyler, what did you do?
I just like added like another 7.
Oh, you put like a p half prime through the middle?
I just put B prime and then B prime or prime. I just added another prime.
Okay. As long as you got the coordinates, that's fine. Number 7, each graph identify the type of rotation and the center of rotation. The shape labeled P is your pre-image, obviously, and I is your image. Okay? 7a, what type of rotation does that look like? And by type of rotation, we mean the degrees of that rotation, right? Coley, what does it look like? 180. About. And then we got to figure out our center of rotation. How can we figure that out? Tyler?
Oh, you can like count on like 1 point or like 1 point on like.
Okay, you can count. Let's take this point since it's on a nice horizontal line. How far away are those points? 6. Well, if I do a 180 degree rotation, I should see a 180 degree angle, which we have here. And my point should be equidistant from the center, right? What does center mean? Center is the middle, right? So my center of rotation has to be in the middle of my prime and my pre-image, my pre-image and my image, right? So if this is 6 spaces away, what's half of 6? 3. So what point is my center of rotation here? 0, 0. My rotation is 180 about the origin. Part B, type of rotation here. How many degrees does that look like? I love that you said 270, Tyler. You're absolutely right. I'm going to go with 90, though, just because it's easier. But 270 is not wrong. We just got to make sure that the direction is right. Yeah, Alex?
90 degrees
Counterclockwise. Well, doesn't it turn this way? Doesn't it turn to the right, or no?
Oh.
How do I know it doesn't turn to the right?
The upright one is the pre-image.
That's right. I got to pay attention. Which one is P? Which one is I? Because if I don't think about that, I could see this and go, oh, it turns to the right, 90 degrees clockwise, right? But I'm starting here, and I'm turning left 90 degrees counterclockwise. Is this one about the origin? No. I'm going to name some of these points. I'm going to call this tippy top point here A and A prime, which would make this B and B prime, and then this point down here is C and C prime, right? What's that? Did I switch them? Oh, snap. You're right. My bad. All right. Now, C and C prime, this is pretty easy, right? Because they are literally just one square away. So if I were to make a 90 degree angle between those 2 points, it would look something like that. Everybody see that?
Yeah.
Well, where does that 90 degree angle meet? Where's the middle of that 90 degree angle? 2, 0. That's my center of rotation. I can try that with A too. A is like 5 by 1. A prime 5 by 1. Boom. That's another 90 degree angle just like that. So we can do it that way. Now, Tyler, if you had written 270 degrees clockwise, is that wrong?
No.
Nope. It's the same thing. 90 counter is the same as 270 clockwise. So you would be absolutely right to say that. Just makes more sense to do 1 turn to the left than 3 to the right. You know what I mean? But you're not wrong. Any questions on the front? Perfect. Let's go to the back. Oh God, I forgot that's what the back looked like. So, for the back, lots of stuff to keep in mind. Let's read this whole little paragraph up here. For each of the problems below, graph the pre-image. Okay. Perform each transformation. Sure. Identify the image coordinates for each new image point, and write the rule if possible. Make sure to label all your points on the graph, use a ruler to make nice straight lines, and place my P1, 2, 3 in a circle in each of the figures. That's a lot of directions, Mr. Church, I know. So my pre-image up here, -3, 4, boom, boom. -7, 1, boom, boom. -6, 5, boom, boom. C, B, A. I'm not going to use a ruler for the sake of time because I want you guys to have time to make your little cards. That's my P. I'm going to rotate 90 clockwise about the origin. What's the rule for that?
Negative y, negative.
Negative y, positive x. So I'm going to take all my y coordinates, 4, 1, and 5. I'm going to flip them into negatives and bring them to the front. -4, -1, -5. What am I going to do with my x's?
Stay the same.
I'm going to keep them negative, but I'm going to bring them to the back. All right. Reflect across x equals 2. What's my rule for that?
A minus 2a
Yep, 2a minus x comma y. A is 2. 2 times 2 is 4 minus x comma y. So I know that all my y coordinates are going to stay the same. Am I going to use my pre-image coordinates or my image 1 coordinates? Image 1. Pre-image doesn't exist anymore. I'm only looking at the most recent coordinates. All my y's stay the same. That's nice. And I'm going to do 4 minus my x. Well, 4 minus negative 4 is what? 8. What's 4 minus negative 1? And what's 4 minus negative 5? 9. So there's my second set of coordinates. So far, so good?
Yeah.
Then finally, I'm going to translate 2, 9. What's the rule there? X plus 2, y plus 9. I'm going to take all my x coordinates and I'm just going to add 2. 8 plus 2 is 10. 5 plus 2 is 7. 9 plus 2 is 11. I'm going to take all my y coordinates. I'm going to add 9. Negative 3 plus 9 is 6. Negative 7 plus 9 is 2. Negative 6 plus 9 is 3. And that's where my final image should be. You guys know how to plot points. I don't need to show you what the triangles look like. Do all those points sound good to you?
Yeah.
Did I already do this? I think I already did this. Let me just show you. I'm not doing it again. Because it's annoying. As I'm sure you found it by doing it. Yep, here it is. Triangles look like that? Yes? Perfect. Last but not least, number 9. 6, 3, 6, 3, 6, 6, 6, 6, 4, 3, 4, 3. This is a tiny triangle. It's a little guy here. Here's my pre-image. Rotate 180 about the point 3, 0. What's the rule for this one? There is none. Here's 3, 0. All right. We can do our little turning turn. Do you guys feel comfortable doing the turning and the points? Yeah? Okay. We can do the shortcut way too. From, what is that, P? Oh, F. From F to my rotation is 3 by 1. I'm going to keep going 1 by 3. Boom. There's F prime at 2, negative 3. D is 3 by 3 spaces away from my center of rotation. D prime is going to be a further 3 by 3 at 0, negative 3. And E is, oh Jesus, 3 by 6. So I'm going to go 3 by 6. Boom. There's E prime at 0, negative 6. I'm going to do that in black so you can see it a little bit better. Does that look good for my rotation? Yep. Now I'm going to reflect across y is equal to x. Well, y is equal to x. What's my rule for that? Yx. So I'm just going to switch all these places. Negative 3, negative 6, negative 3 all come to the front. 0, 0, 2 all go to the back. Translate 5, negative 8. X plus 5, y minus 8. I'm going to add 5 to all these numbers. 2, negative 1, 2. I'm going to subtract 8, negative 8, negative 8, negative 6. Does that look good for the coordinates? Yeah. Yep. Does that look good for the triangles?
Yeah.
Give me a thumbs up if yours looks like that. Okay. Perfect.